I said this one. So last time. We started with A-levels Equilibria, which was that it was application of Equilibria. I told you that there's an ionic product of water. That's the first one. That's known as Kw. That's Kc basically. But it's Kc applied to the dissociation of water. And I told you that water ionizes, it produces two ions, H plus one and OH minus one ions. And so water ionizes, and the better equation for water ionizing is this one, or the more correct version. It's water reacting with water and producing OH ions and H3O plus one ions. I told you that your H3O plus one ions are actually H plus one ions. Whenever you say H plus one aqueous, that actually means H3O plus one. But anyways, your Kc was the product of the concentration uh, of the of the products divided by the concentration of the reactant. Water is not going to be taken as it's going to be taken as one because whenever something is aqueous, the concentration of water is almost constant because it's in large excess. Aqueous solutions, water is always taken as one because it's in large excess. Its moles will barely change throughout the reaction. And I told you that this other reaction was kind of the same thing. If I took Kc for that, water would be taken as a constant. So these two expressions were exactly the same. They were equivalent. So all you had to know was you had to understand this fact that your H3O plus one ions or hydronium ions will also be referred to as H plus one aqueous. So is this clear what Kw is? Is this clear?
Yes, sir.
ठीक है.
सर राइट वाले में KCH2O स्क्वायर जो है कंसंट्रेशन का उसमें KW स्क्वायर नहीं होगा?
No, you combine the constants together. Na? Kc is a constant, water concentration is a constant. So this constant is known as Kw. I mean, this entire thing
अच्छा,
is,
ओके,
ठीक है?
सही.
But you combine all the constants together and you just call it Kw. Yeah, in simple words, basically what you're doing is you're not including water in the expression. Is that clear?
सही है.
I said now the thing is, so I said from now on, remember they can be interchangeably used, but I'm going to stick to this one because that's the one that's more frequently used. But don't forget that H plus one would sometimes be written as H3O plus one. I said, anyways, what is the purpose of this thing? I mean, the application of Kw. Why do we have Kw in the first place? So the first thing is what is like extremely important. Every reaction on planet Earth almost happens in water. So when water ionizes, it produces two ions. One is H plus one, and the other one is OH minus one ions. But under standard conditions, remember this is at 25 degrees centigrade and 1 atmosphere pressure. The amount of H plus one is going to be, and the amount of OH ions is going to be very less. The concentration is 1 times 10 power minus 7 mole per decimeter cube. And the concentration of OH ions is also exactly the same. Is that clear? So both of them are 1 times 10 power minus 7 mole per dm cube, which is like very small. That means water ionizes extremely weakly. It doesn't really ionize a lot. Is that clear?
यस.
Yes, sir.
So what is the value of Kw? Kw was what? It was the concentration of H plus 1, the ionic product of water. It was H plus 1 concentration multiplied by the OHN concentration. So the value of Kw under standard conditions, room temperature, that's going to be 1 times 10 power minus 7 multiplied by 1 times 10 power minus 7. So that's going to give you 1 times 10 to the power minus 14. And the unit is going to be concentration times concentration. So it's mole squared dm minus 6. Is that clear?
यस,
Yes,
सही
sir.
है सर.
Okay, so remember Kw now this value you have to remember. It's a very important value. And so why is it important? So the first thing is why is water important? So all reactions that are happening in water in your cells everywhere, TK plants, animals, all reactions pretty much are happening in water. 70% of the Earth's crust is water. Now, what happens is that if you have a neutral solution, the concentration of H plus 1 and the concentration of OH ions as shown above, that's equal. That's known as a neutral solution. But when you add an acid to it, what does an acid do? It produces H plus 1 ions, right? So the concentration of H plus 1 goes up and the concentration of OH ions, it goes down. Is that clear?
Yes, sir.
Because the acid produces H plus 1 and hence, or it neutralizes the OH ions. So the H plus 1 goes up. So that means the solution is now very acidic. But the value of Kw still remains exactly the same. What was the value of Kw? It was 1 times 10 power minus 14. What's the value of Kw? Because it's a constant, right? So the value is still 1 times 10 power minus 14. If one goes up, the other goes down, but the product remains exactly the same. Is this clear?
Yes, yes, sir.
Yes, sir.
ठीक है और alkaline solution में what happens is that H plus one you have fewer H plus ions and the OH ions go up. So that means the solution is so the OH ions are going up. Vice versa, the H plus one ions and the concentration goes down. So that makes the solution alkaline, but the value of Kw still remains 1 times 10 to the power minus 14 mole squared d minus 6. So it comes out to be always the same. As long as remember all cases they only change with temperature. That's the only thing that changes the value of Kc. So this also applies to Kw. Kw only changes with temperature. Can you guess whether there's going to be more dissociation at higher temperature or less dissociation?
More
ठीक है, because the molecules will be more energetic.
dissociation.
They'll be colliding with each other a lot more. So there's going to be more dissociation. So at higher temperatures, if you increase temperatures, you have more dissociation. And because of that, your Kw is going to be higher as well. So remember this, that the dissociation of water is going to be, you're going to have more dissociation at higher temperatures. ठीक है, so is this clear that Kw remains a constant? Is that clear?
Yes, sir.
Yes, sir.
Okay, now tracking this is like very important. Why? Because all reactions, I mean, you have to always track because all reactions, like your stomach, it's every reaction requires a certain pH. It requires a certain balance of H plus one and OH. And some reactions prefer neutral conditions, some prefer acidic conditions, some prefer very acidic conditions. So every time, that's the first thing when you're doing or studying or analyzing chemical reactions, that's the first thing that you study. You try and figure out what the pH is. If the crops are not growing, you're going to look at the pH. Is it the right pH or not? Is it the right balance of H plus one and OH ions? If your stomach is upset, that's the first thing that everyone looks at. If there's something wrong with your blood, you're going to check the pH first. Is it the right pH? Because the balance, if this balance changes, the reactions are going to get affected. So we always want to track this, right? So chemists always track H plus one concentration and well, they track just one of them because the other one is like the opposite. If H plus one is higher, then automatically you understand that OH ions is lower, right? So you're not tracking both of them, you're just tracking one of them, actually. The other one is understood. It's just going to be the reciprocal of that. So chemists always track H plus one and OH ions. Now, and they make graphs about it. Like if you're planting crops, like every day you're going to check the pH of the soil, and the best way to visualize data is to make a graph. So visualizing data, that's very important. So you have to make a graph as well. Now, so the best thing to make a graph, you For graphs, remember this. Whenever you try to make a graph, you always have a problem with range. Okay? It's very hard to figure out what the range is. So, for example, the concentration of H ions in the soil could be zero point 0.1 mole per dm cube. I mean, it could be zero point 0.1 mole, like it could be very acidic. Or if you neutralize the acidic soil, it might become very less. Or if you add too much alkaline to the soil, then the concentration of H ions would go down to a very low value, right? So so you're trying to make a graph out of these values. Now the first thing is it would be very hard to figure out a range if you want to plot these values, right? Remember, graphs are very difficult to draw if the values are either too big or too small. ठीक है? Is that clear?
Yes, sir.
Yes,
ठीक
sir.
है. Like if it's very hard to plot a very small value, right?
Could you scroll up for a while? I just needed to copy something.
ठीक है. This one?
Yeah.
अच्छा. अच्छा, but is this part clear that making graphs with values that are completely out of range, ठीक है? One is too big and the other one is too small. That's very difficult. So what they do is they don't plot these values. What they do is they make log graphs. Do you know what log is? Like if you haven't studied math, okay, I'll tell you what log is. What log does is that log expresses these, and we're talking about base 10 log. So what log does is that it converts these values into powers of 10. So what is point one? Point one in powers of 10 is 10 power minus 1, right? What is this other one? That's okay, this is 10 power minus 4, right? And what is this value? That's 1, 2, sorry, 1, 2, 3, 4, 5, 6, 7, 8. I think 10 power minus 8. Okay, so what log does is that it converts these values into powers of 10. So if I take the log of point 0.1, I mean, you've got a calculator, it's got a button on it. Uh, you can just press log and take point 0.1 as take the log of point 0.1. Now, log would give me minus 1. It's going to tell me that 10 is going to have a power of minus 1. This one would give me a power of minus 4. This one would give me, if I take log of this, it's going to give me minus 8. Okay, is this part clear that log, what does log do? It converts the values into powers of 10. Is this clear?
Isn't the first one 10 to the power minus 2 though?
No, it's minus 1. I mean, you can check the log. Use your calculator. Take log of point 0.1. It's going to give
Oh,
you,
okay. Okay,
okay.
got it.
It's 1 over 10 basically. I said, but is this part clear that so what you do is the first problem was that it was very hard to plot these values, right? On a graph. So you took log. Now log is going to give you, and I'm just going to ignore the negative sign for the moment. I'm taking negative log. I'm actually multiplying them with minus 1 because no one likes negative values. So we just ignore the negative sign. Okay, I'm going to explain that later on. So now tell me, is it going to be very easy to plot 1, 4, and 8 on a piece of graph paper?
Yes, sir.
Okay. So instead of plotting point 0.1 and point 0001 and point 8 zeros and then 1, it's a lot easier and it's a lot clearer as well. It's a lot easier, a lot convenient to plot 1, 8, 1, 4, and 8. So so everyone prefers in science, everyone prefers log graphs. Because the good thing about log graphs is that it solves your problem with range. Like you don't have to choose a range. It's like what's the biggest number? That's 10 power 10, right? You take log, it's going to give you 10. What's the smallest number that you can think of? That's 10 power minus 10. You take log, it's going to give you minus 10. So your graph and its ranges are not going to be that huge. So is this point clear that every time you make log graphs, is that clear?
Yes,
Yes,
sir.
sir, समझ आया.
Yes, sir.
Okay, so what we do is our purpose was that we wanted to track the concentration of H plus on OH ions, right? Because it was very important to us. So I've got this KW expression. So what I'm going to do now is what is KW? KW is H plus 1 concentration times OH minus 1 concentration, right? So, and it's got a value of what? 1 times 10 to the power minus 14. I'm going to take the negative log. Remember, I'm taking negative log because I did not like the minus sign. So I put a minus sign over there just to get rid of all the minus signs because no one likes to make a graph that has minus values, right? So, so we're going to take negative log on both sides. What are we going to get? It's going to be minus log of H plus 1 concentration multiplied by OH minus 1 concentration. And the other one is minus log of 10 to the power minus 14, right? This is what we're going to get. Now remember, when you multiply two things, in terms of log, they add up. I mean, for example, if I'm multiplying 10 power 2 multiplied by 10 power 3, right? Tell me what's the answer for this? Like, this is basic math. What do you get over here? What do you get in powers of 10?
10 to raise power 5.
Power 5, right? So in terms of log of 10 power 2 is 2, log of 10 power 3 is 3, and log of 10 power 5 is 5. So there's a property of log which is that if you multiply two things, in terms of log, it's actually getting added up. Is that clear? So multiplication, actual multiplication in terms of log changes into addition. Okay, that's a property of log. But is that clear? Does that make sense?
Yes, yes.
Okay. So, so if I rewrite this, this becomes minus log of H plus 1 concentration plus minus log of, so the plus is going to, it's just going to be redundant. I'm just ignoring the plus. Minus log of OH minus 1 concentration. And that's equal to minus log of 10 power minus 14. Okay. So again, I'm just going to recap everything. Just telling this in detail because a lot of people haven't studied log. So I took log on both sides. Okay. What log does is that it just expresses the value in powers of 10. And I told you that there's a property of log, which is that if two numbers are getting multiplied and you're getting a third number, in terms of log, they're actually getting added up. Log of 10 power 2 is actually, log expresses it in powers of 10, so it's 10 power 2. This is 10 power 3. So in terms of log, they're actually, this is, if I take the log of this is 10 power 5. So in terms of log, they're getting added up. So multiplying two things in terms of log, they're actually getting added up. This is addition. It's just a minus sign over there. So it actually turns into, I mean, you add the negative sign over here. So anyways, is this clear up till this point that we got this expression? Is this clear?
Why did you multiply by minus log on both sides?
As opposed to log, right? Like, what is your question? Why am I taking log or why am I taking minus log?
No, you said minus log.
Yeah,
Yeah, why?
instead of log, right? I mean, reason is remember, I told you the concentrations, right?
Mm-hmm.
If I took just log, what do I get over here? I get minus 1, right? This is 10 per minus 1, right?
Yeah.
This is 10 per minus 4,
Oh, you
right?
don't want minus, that's why.
I just don't like minus values, right? So I just multiplied everything by a minus sign just to get rid of the minus values because the concentrations
But
are
we could get negative as well.
yeah because the thing is the concentrations are always smaller values. Concentration, I mean, you don't have uh you're not going to get 1000 mole per dm cube, right? So if you take the log of that, that's 10 power 3, you're going to get 3, right? So when you're tracking concentration, it's never going to be 1000 mole per dm cube. Is that clear? So you're never going to get a positive value. Do you get my point? It's always something small. Concentration is always something small, right? So the value
Mhm.
would always, in terms of log, it's always going to come come out to be something negative, right? 10 power minus 8, 10 power minus 4, 10 power minus 1. And I don't like minus values. So which is why I multiplied everything by a minus sign. So that's where the minus sign is coming in. So anyways, we got this, right? हाँ जी.
If we use like we have large values like 1,000 and 100,000 something like that, तो फिर हम minus log की जगह सिर्फ log का graph लेंगे ना? We won't use minus
No,
log.
but the thing is, when you're tracking concentration, you're never going to have 100,000 mole per dm cube. Is that clear? The
Sir,
max,
sorry, आप क्या बात कर रही थी? Can you repeat?
नहीं, मैं वो कह रहा हूँ 100,000, like if you're tracking concentration, right? So
Yes, sir.
you're never going to have 100,000 mole per dm cube. Do you get my point?
Yes, sir.
ठीक है, so that
मेरे पास
discussion,
maximum
हाँ,
कितने तक हो सकता है?
कौन सा?
Like 1,000. मतलब हमारे पास कितने तक हो सकता है? Like the range for large.
नहीं, that is not a problem that we are trying to solve right now, ना, क्योंकि हम तो we're just tracking concentration. Putting the minus sign solves our problem, right?
Okay, sir.
उससे आगे मतलब वो फिर कोई और प्रॉब्लम होगी, we can apply other rules to that problem, ठीक है? I mean, for this problem, this is enough, ठीक है? Now,
Could you zoom out so I could just take a screenshot?
okay. So now the last thing, ठीक है, which is we got this expression, right? What is this expression? Now, this expression is actually your pH. ठीक है, the pH thing, ठीक है, I'm zooming in now. So this entire thing minus log of h plus 1, that's referred to as pH. ठीक है, the thing that you've always talked about, that's pH. This other thing that we normally don't talk about, that's pOH. ठीक है, and I told you why we don't talk about it. Because I told you that if you're tracking H plus 1, the OH ion is like behaving in the opposite way. And what do you get for minus log of 10 power minus 14? That's going to be 14, right? So I get this expression now, which is pH plus pOH is equal to, and that's equal to 14. Is that clear?
Yes, sir, सही है.
ठीक है, so this expression changes into this. So pH plus pOH, just remember that we never talk about pOH. I mean, we can talk about pOH, but normally we don't talk about pOH. We talk about pH, always pH. Even for bases, we talk about pH, right? Is that clear?
Yes, sir.
Yes, sir.
So make sure you know this, or you should know this, that this thing P stands for minus log. It's going to appear in a number of places. Whenever you see P, anything like PKC or P something, PKSP or anything, P just stands for you're taking negative log of that. Keep that in mind. So you've got pH plus pOH is equal to 14. Now, there is no difference. I mean, these two things are exactly the same. One of them is just a log version of the other thing. Is that clear? Like this KW being the ionic product of water, this is just the log version of the same thing. Is that clear? But these two are exactly the same thing. What this does exactly the same thing. Is that clear?
Yes, sir.
Yes.
ठीक है. So we know what pH is now. Uh, and remember this identity as well, because if you know pH, it's equal to 14, you can figure out pOH as well. So if you know one of them, the other one, you would automatically know what the other one is. You know pOH, you will figure out pH directly. So we're gonna start doing questions now. The first one is easy. The first one is about strong acids. How do you calculate the pH of strong acids? This is what we're gonna do now. So the first one is now strong acids and strong bases. And we're going to learn how to find the pH of these. Uh, the first thing is they fully ionize or dissociate. Uh, so ignoring the organic acids and organic bases, pretty much all the other ones are strong acids. Uh, but we'll talk about this in detail. Fully ionized, I mean, let me let me discuss this in detail. Um, See, strong acids and strong bases, that doesn't ionizing something doesn't mean that it's going to be 100% ionizing. Uh, it's going to be very close to 100%, but it's not going to be exactly 100%. So keep that in mind first thing. Uh, because we're going to start studying weak bases and weak acids as well. So fully ionizing does not mean that 100% of it, just something very close to 100% ionization. So I've got HCl, right? This HCl will ionize and it will produce H plus 1 and Cl minus 1 ions. So let me just Google this. What percentage of HCl ionizes in aqueous solution? Like I'm just trying to see if I'm able to find. What's the Kc? Wait a second. Okay, so I don't know if this is 10 past 7, 107. So I'm going to discuss that later, just a second. We're going to come to that. Okay, I can't find the value. Anyways, what I was discussing was HCl ionizes. You've got zero point 0.1 mole per dm cube. So at the moment, if HCl is zero point 0.1 mole per dm cube, right? That kind of indicates that it's almost 99.9% of it will ionize. So you will approximately have zero point 0.1 mole per dm cube of H plus 1. And I don't care about Cl ions. So you're going to have zero point 0.1 mole per dm cube of H plus 1 ions in aqueous solution. Is that clear? So it's pretty easy to figure out what
Yes,
Yes,
H.
sir.
I said it's pretty easy to figure out what H plus 1 is. There's going to be water as well because remember HCl is not alone. There's going to be water as well. But we're going to ignore the water ionization because water ionizes like extremely weakly. Like what was the concentration of H plus ions in water? That was like 1 times 10 power minus 7, right? So that was like almost negligible. So when we have a strong acid, we just assume that, and in the case of like if H percent concentration is like very high, this equilibrium is going to shift backwards, right? So the concentration of H percent coming from water, that's going to be even lower, right? So so in when an acid is present, the water basically all the equilibrium shifts backwards and it barely ionizes. Is that part clear as well? So we're going to assume that almost nothing is coming from water, right? All the H plus ions are coming from the strong acid, which is HCl. Is that clear?
Yes, sir.
So pH is pretty easy. pH is, what did I tell you? It's minus log of the concentration of H plus 1, and that's going to give you what? It's minus log of the concentration of 0.1, and that's going to give me 1. So the pH is 1. Is that clear?
Yes, sir.
लेकिन सर अगर रिएक्शन एक्सोथर्मिक हो और वाटर हीट अप हो तो उसमें आयनाइज ज्यादा नहीं होगा?
नहीं, लेकिन water itself is ionizing very weakly, right? तो
अच्छा, okay,
कितना आयनाइज हो जाएगा? ठीक है. I mean, the
ठीक है.
amount of ionization would be still very, very less, right? Even if it's heated up. Acha, what about a base then? ठीक है, so we found the pH of water. That's very simple. So you figure out the pH of HCl. Now, what if we have NaOH? Now, NaOH is a pretty strong base as well, and it fully ionizes. Again, that does not mean that it's going to 100% ionize. 99.99%. So it almost completely ionizes, produces Na plus 1. So if I have, let's say, 0.2, let's pick another value, 0.25 mole per dm. Now you would have to use a calculator to figure out log. So the amount of OH ions is going to be, I don't care about the Na plus 1 ions. The amount of OH ions would be 0.25 mole per dm cube as well. Now the problem over here is I can't find pH, right? The reason I can't find pH is there is no H plus 1. I mean, at least in the equation, in the reaction. What I'm going to find out is I'm going to find out POH instead. Is that clear? And POH is what? The negative log of the concentration of OH ions. I'm going to do that, and it's going to give me negative log of. Can somebody tell me what the value is? Just remember, just remember, log is just a button on your calculator. What do you get for this?
0.6.
ठीक है, so you're getting point नहीं कितने three significant figures 0.6.
02.
ठीक है, so you're getting 0.602. But that's pOH. And remember, I told you we don't deal with pOH. We always convert that into pH. And we know that pH plus pOH is, we figured that identity out. pH plus pOH is equal to what? 14. So my pH is what? My pH is going to be equal to 14 minus my pOH, which is, so it's going to be what? 14 minus 0.602, right? Which is going to give me what? क्या आएगा?
13.40.
So that's going to give me 13.40. So that's my pH. Is this clear?
Yes, sir.
Yes.
Yes,
ठीक है?
sir.
So there are two examples: strong acids, strong bases. Just remember, for bases we go for pOH, but then we convert that into pH because
So for weak acid and bases, will we be doing it as well?
yeah, we'll be doing that. That's going to be more complicated. Okay, that's going to
And
be
would that include water? Water is neutral though, but like
yeah, but water, you're going to still assume that the ions coming from water are like negligible.
okay.
Okay, because
And
it's
water is still considered neutral, right? So it's like 14. No, I mean not 14. It would be
what's a like that's a good question. What's the pH of water, right?
yeah.
Like the pH of water. So I told you that. Where did I tell you that?
Because there's both H plus and OH, and when they add together, it's like 14. So
No,
like
it is
what?
it is 14, but remember pH of water, right? So that is the negative log of the concentration of H plus ions, right? So in water, the concentration of H plus 1 is what? 1 times 10 power minus 7, right? And that's
Yeah.
that's going to give me what? 7. Is
Mm,
that clear?
yeah.
ठीक है. वो 14 जो था, that was the product of both things, right? That was the H plus 1 getting multiplied by the OH ions, right?
So there's nothing like there's no like pH or anything when there's both present. Like when both
नहीं नहीं,
H plus.
there is always pH. Like,
Okay.
and they're always both present at the same time. Like, remember
That's
this.
why it's neutral, right?
They're always I mean, both of them are present. Both of them, when they're equally present, that's when it's neutral. Is that clear?
Yes.
When you have an acid, that does not mean that the OH ions are not there. It's just that they're going to be lesser in quantity. When you have an alkali, that means you've got more OH ions, but you're going to have less H plus ions. So they're always, both of them are going to be present. And so I figured out the pH of water, right? pH is what? It's the negative log of the concentration of H plus ions, right? So in neutral water, H plus 1 concentration is what? 1 times 10 power minus 7. So I just took the log of that and I got 7. That's why water has a pH of 7. Is that clear?
Yes, sir.
Yes.
ठीक है. अच्छा, now there's another way of solving this as well. This is, I use this thing, the negative log of H plus 1, right? The other way is I could have solved this using KW as well. Uh, I mean, not this one, but this one, the second one. This one was direct because I wanted to find pH, so the concentration of H plus one was already there, right? This one, I used the pH plus pOH is equal to 14 identity, right? What I could have also done was I could have used KW. Remember, I told you that that KW and this pH plus pOH thing, they're both exactly the same. There's just this one is just a log version of that. So, so the NOH thing, I could have used KW. I knew that KW is H% concentration multiplied by OH ion concentration, right? And I knew the value of KW. That was what? Under room conditions, it was 1 times 10 power minus 14. I knew the OH ion concentration. I did not know the H+1 concentration. The OH ion concentration was given over here in the question. It was 0.25. So using that, I can figure out H+1 concentration. What do I get if can somebody solve this? 1 times 10 power minus 14 divided by what? 0.25.
4 multiplied by 10 to the power minus 14.
एक second. So I get 4 times 10 power minus 14, which you can see that's like a very, very low value, right? Because it's an alkaline solution, right? When you have an alkaline solution, the concentration of H plus one is going to go down, and it's going to be very, very low. And you can then take the pH. You can take the negative log of this. So what do you get if you take the negative log of this?
13.4, same.
You're getting 13.4. So remember, you've got two choices. You can either use the pH plus pOH thing to solve this question, or you can figure out use KW without the log and then take the log at the end. Is this clear?
Yes, sir.
Okay. Just remember, this thing can get very confusing as well, but keep it simple. Okay. Just remember, you've got KW is equal to H plus 1 and OH ions, and the value is equal to 1 times 10 power minus 14. And this is the log version of the same thing. And you can use both of them to solve the question. Now, one thing you should also know is that how to get out of log. I mean, you're calculating logs, right? So if I tell you, if I do a reverse question. So if I tell you that the pH of HCl is let's say um, 1.8, and I ask you to find out the concentration of HCl. So you need to know how to do the reverse as well. So this question over here. So remember, the pH is already known. It's 1.8. HCl ionizes fully, and when it ionizes, it produces two ions. One is H plus 1, and the other one is Cl minus 1. Now, the pH is already known. What is pH? pH is the negative log of concentration of H plus 1 ions, and that's equal to 1.8. Now, remember the quick way of going back. Finding pH is you take the negative log. There's a button on the calculator, you just hit that. When you want to go back, just remember, if somebody tells you that pH is 1.8, that means without the log, without the p, without the negative log, the H plus 1 concentration is 10 to the power minus 1.8. That's the reverse. Is that clear?
Yes, yes, sir.
Okay.
Could you repeat
Yes,
again?
sir.
I mean, I'm going to do this in a simple way first. See, what's the negative log of 10 power minus 5? What do you get? 5, right? Is that clear? So that means negative log is what? P. you want to go back, if you want to go back and you've taken, I mean, you have 5, right? So let's say this is H plus 1. So the pH is 5, for example. I mean, this was, okay, let me do it this way, 1 second. So pH is coming out to be 5. So that means the negative log of the concentration of H plus 1 is coming out to be 5, right? And the only way that could come out to be 5 is that the negative log of H plus 1 concentration is actually 10 power minus 5. That's why it's coming out to be 5, right? So I want to go back. So whenever you see 5, whenever you see pH is equal to 5, that means H plus 1 concentration is what? It's 10 power minus 5. So whenever you see or somebody tells you that pH is 1.8, that means the concentration of H plus 1 is 10 power minus 1.8. If you take the log of this, the negative log of this, you're going to get 1.8. Is that clear?
Yes, sir.
Yes, sir.
Yes.
Okay, so if pH comes out to be, I mean, you have to be quick with this because people get confused with this. If they say pH is equal to 2, immediately know that the concentration of H plus 1 is 10 to the power minus 2. You take the negative log of this, you get 2. If somebody says that the pH is 13, right? Immediately know that the concentration of H plus 1 in this case is 10 to the power minus 13. Is that clear? So you have to be good with this to get the conversion. You know the concentration, you take the negative log, you find pH. You've got the pH, you take the inverse and you find out the concentration. Is this clear, this conversion?
Yes.
Yes, sir.
Yes, sir.
And so what about the pOH if we have like pOH and we don't know the pH?
No, same cheese, like for example, if you have pOH, right? And they tell you that the pH is 2. So that means the concentration of OH ions is 10 to the power minus 2. Huh.
Okay, sir.
But then again, if you wanted to find pH using this, then you could have converted pOH into pH plus pOH is equal to 14 karke. You can convert that into pH and then you can find H plus 1. Achha, but anyways, make sure you know this conversion. Okay, you have to be quick with this. So remember in the question, they told me that the concentration of the pH was 1.8. That was what the question was. The concentration was, sorry, the pH was 1.8. And using that, I'm able to figure out what H plus 1 is. Can somebody solve this and figure out what H plus 1 is? What is 10 power minus 1.8? What do we get for this?
0.016.
नहीं तीसरा नंबर क्या है?
अच्छा 58 है 6 की जगह
अच्छा 0.01.
58.
अच्छा 158. अच्छा, so this is the last one. अच्छा, anyway, so it's 0.0158, right? So it's a strong acid. So that means HCl concentration would also be exactly the same. So it's 0.0158 mole per dm cube. Is this clear?
Yes, sir.
Yes, sir.
Okay, so just remember that if you have pH, immediately you can figure out what H percent concentration is. That's going to be 10 power minus 1.8. You'll figure that out. You know the H plus 1 concentration. It's a strong acid, so HCl concentration would be exactly the same. Okay, is this clear?
Yes, 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 sir.
Yes, sir.
I just remember this whole thing, taking log and anti-log and the whole thing, that gets very confusing, okay? Especially for people who are not used to a lot of math. So just make sure you know this thing. I mean, this last thing, how to do the conversion. Okay? So, okay, we'll continue with this tomorrow then.
Okay, sir. Allah Hafiz.
Okay, take care.
Okay, sir.
Thank you, sir.